Good morning to everyone. I would like to wish you a warm welcome to our new training session. We are thrilled to have join us today two great trainer and speaker, and I would like to join you in our 9th training session on series standardization in practice related on metrology standards. Thank you for your time and willingness to spend it with us. My name is Ivana Mijatovic and I'm lead of HS Booster Training Academy. And today, as I already told, we have fantastic speakers. Join us today are Elsa Batista, head of the Volume and Flow Laboratory at the Metrology Department of Portuguese Institute for Quality, and Eric Smith, Chief Metrologist at Flow at WSL, the National Metrology Institute of the Netherlands. I will say a few words about our presenters today. Elsa Batista has been responsible for the Volume and Flow Laboratory at Portuguese Institute for Quality since 2002. She has started working there in 1999. She serves as the convener of a volume subgroup of the Euromet technical committees and as a Portuguese contact person for this committee. Since 2002, she has also been a technical auditor and trainer in the areas of volume and flow. Elsa is a member of several international standardization technical committees, including ISO TC 48, ISO TC 28, and ISO TC 84. For the contribution to standardization activities, she was awarded the Senelec Standards Plus Innovation Award in 2023 in the individual researchers category. Elsa has participated in the development of several national and international guides, including Euromet CG21, CG19, and CG27 in the area of volume and flow metrology. She was coordinator of the Euromet International Project Metrology for Drug Delivery 2 and is currently coordinating a project establishing metrology standards in microfluidic devices. Few words about our distinguished presenter today, Eric Smith. Eric Smith is a chief metrologist for flow at WSL, the National Metrology Institute of the Netherlands. As a chief metrologist, Eric primarily works on international projects in metrology, ensuring the best possible measurement solution for customers and other stakeholders of WSL. Over his 31 years with WSL, he has built several national measurement standards, with the last being brand new water flow facility at the new location of the Port of Rotterdam. This location, known as the European Center for Flow Measurement, aims to be the best of its kind. Eric remains involved with the facility in obtaining accreditation and publishing its capabilities in the KCDB database, where national metrology institutes list their best calibration possibilities. In the past, Eric was part of the management of the WSL, where he led several teams in all aspects of metrology. In 2022, he decided to leave management team to pursue his passion in metrology at the highest level of chief metrologist. Since June 2023, Eric has been the chairperson of Euromet TC Flow, collaborating with colleagues from around Europe to ensure the development and maintenance of measurement standards in the field of gas flow. liquid volume, fluid speed, and liquid flow. He has contributed to development of various standards, guides, and recommendations for organizations such as Euromet, ISO, and OEML. During his work, Eric has trained many people through various training courses and presentation at international conferences and workshops. His personal goals are to ensure that the knowledge gained by metrologists is passed on to the new generation and companies that can benefit to make the world sustainable for the future. Let me say just a few words about today's training. So metrology standards play a crucial role in research across various fields, and they are indispensable for researchers, providing the foundation for accurate, reliable, and reproducible scientific measurements across the disciplines. I'm eagerly anticipating the insight of trainers, and I'm happy to have a chance to hear from that. Please note that today's webinar will be recorded and a copy will be available on our website as soon as possible. Additionally, we will share relevant resources and material, and we would like to receive your feedback. Please feel free to use our chat Q&A feature and share your thoughts or ask any questions to our trainers today. Elsa, floor is yours.
Hello, good afternoon, or good morning in this case, well, wherever you are. So my name is Elsa Batista. Thank you very much, Ivana, for the invitation to be here, to give you this presentation and to participate in this training session. And I'm here to show you something about establishing metrology standards, so some research project outcomes, and also how to connect actually metrology, standardization, and research, like Ivana was explaining in the beginning of the session. So first I'm going to tell you something about IPQ. IPQ is the Portuguese Institute for Quality, is where I work for the past 25 years as the head of the Volume and Flow Laboratory. And IPQ is a public institute, also created in 1986. And it's an institute in indirect administration of the state. And it has the mission in Portugal to coordinate the Portuguese quality system. And it's also the National Metrology Institution and also the National Standardization Body. So IPQ has these two main functions in Portugal. So as a national standardization body, IPQ has a lot of responsibilities. Mainly, it coordinates the standardization subsystem in Portugal. It also promotes and supports the development of national normative activities in a credible and sustainable way. Also, it has a responsibility for editing, disseminating, and also to sell the standards and other normative documents, all at international, European, and national level. And it facilitates the dissemination and implementation of best practice, contributing to competitiveness, productivity, and innovation of products and services. And then, as National Metrology Institution, IPQ has the responsibility to coordinate the subsystem of metrology and ensuring the rigor and accuracy of all the measurements performed, and also the comparability and traceability at national and international level. It has the commitment to realize, maintain, and develop the national standards of units of measurement. So all across Europe or all across the world, each country has a national metrology institution who takes care of the national standards of the country, and this is one of the activities of IPQ. And also we have activities in both scientific, applied, and legal metrology. So the objective is to survey the field of measurement standards and also to control the necessary measurement instruments for industrial and Portuguese society in general. So these are two bases of IPQ. So as you see here in this slide that IPQ as the National Metrology Institute has also these three fields of activity. So in the scientific metrology, you have here National Metrology Laboratory, and also then we have designated institutes. That means that for some measurement quantities that IPQ cannot do, we assign other laboratories in Portugal that can be our reference standards keepers for some quantities. So we also work in terms of applied metrology, giving also some help to the accreditation laboratories. And in legal metrology, IPQ is also the keeper of the procedures for activities in verification and qualification of entities. And we are part of the Meter Convention since 1875. So we are part of the by APM signatory mutual recognition agreement for some time now. The metrology department itself, as you have here more or less how we are organized, but mainly we have different activities, division, for example, length, time, and frequency, photometry. So you have here all the quantities you can see in the International System of Units that later on Eric Smith is going to talk about. We have all this capability here at IPQ. And our laboratory, the volume and flow laboratory, fits here within this subsection of mass, volume, and liquid properties. In our National Metrology Laboratory, we have around 3,000 calibrations per year. We are very engaged in research projects, around 18 in total. And we have also a very important number for publications. So last year we had 63 publications and our presentations in conferences. And we are around 41 persons working in our metrology department, and we have around 52 technical metrological domains. And here are some pictures of what you could see in our National Metrology Laboratory. So many fields of activity, like I told you, 52 is not possible to explain all of them to you here today, but I can explain one of them, which is the one I work, which is the Volume and Flow Laboratory. So in the volume and flow laboratory, we make calibrations to industry, mainly water meters manufacturers, fuel companies, also chemical, analytical, and pharmaceutical laboratories. And in this slide, you have also an idea of the different kind of artifacts we can calibrate in our laboratory in terms of volume. So from the small glassware micropipettes to the big tanks that are also available, also used to verify gas pumps. And these are also an image of our laboratories. We have a range in volume from 0.1 microliters up to 10,000 liters. And this is the largest range for measurement of volume in the world. And in terms of flow, we also calibrate dosing devices. And this one, maybe you are familiar with it. So it's a syringe pump used for the hospitals. Also, we calibrate flow meters, like you see here in the first picture. And we use very different methods to do this. So to determine flow, we use gravimetric method, interferometry. We use also optical methods, like you see here in the camera. So there are many different methods we can use to calibrate different artifacts. And in this case, we also have a very large range for measurement of microflow. Now, in terms of quality infrastructure, here you can see the three main pillars of what happens. And we have the National Accreditation Body, we have the National Standards Body, and the National Metrology Institutes. And all the three of them have to work together so we can benefit authorities, consumers, and general public with the work we do in standardization and metrology. So in terms of standardization, it is the process of implementing, developing technical standards based on consensus. And this is a very important word that I want you to keep in mind, because only with consensus from different parties, we can actually achieve very good documentation. And the different parties include firms, users, interested groups, standard organizations, and governments. So all these actors are part of the consensus that will define a standard. And standards are based on transparency, openness, representativeness, impartiality and consensus, again the word, coherence, and effectiveness and relevance. And if we combine all these 6 aspects of standardization, we can see that standards are the common language of the world, because everyone that participates in a document can then use them all around the world. And that is very interesting when we have a document based on consensus that everyone agreed on, and then that it's used all around the world. So you can see the impact of such a document. And standardization has several main objectives. First is the formulation of the document itself. Then is the diffusion of the document by the world, and the application of the norms in several fields of science, technique, economy. And the objective is to obtain benefits in the best application of products, processes, and services to the purposes to which they are intended, and elimination the barriers of trade. So this is also very important when you have a document that has some specification on products or processes, and then can be used all over the world. So if you have a standard, for example, of a screw, you can use them all around the world, so everyone can use the same product and manufacture the same product in the same way, because it's written how to do it. So what means that standardization can help maximize the compatibility, interoperability, safety, repeatability, and quality of your product. So you can see here also in this picture the 10 pillars of standardization that are very, very important for society. So what are standards? So I'm going to give you here just some information of what they are actually, and what are they used for. So they are technical documents. That's everyone knows that. And they are resulting of a consensus, and they are approved by a recognized standardization body, and they establish rules, guidelines, or characteristics of products or services, processes, and technology. They also provide something very important, which is the requirements of the quality of an instrument, for example. They are based on consolidated results of science, technology, and experience. So this is also very important. All the content of the standards are always proved and always validated by the technology. So in terms of metrology standards, especially these ones, all of them, when we decide on a procedure, a technical procedure that works, and that everyone agrees, we still have to provide validation of how this procedure works by various institutes. So it really, we need basis of data from science to proceed with a document and a technical procedure in a standard. And what these standard documents aim to optimize and benefits for the community. And normally they are not binding. That means they are voluntary use. So a laboratory can apply a specific standard in their activities if they wish, unless there are legislations that has a mandatory information about the use of these standards. So it's important also to see these 2 aspects, but in principle, all these documents are voluntary. There are several types of standards depending on the level of the scope of the standardization body that is responsible for its publication. So we have levels at the ISO level, so international standards, and normally these are standards accepted all over the world. Then we have, for example, European standards. So in this case, it will be the CEN, the Comité Européen de Normalisation. that is responsible for the implementation of these standards in Europe. But for example, if you go to the United States, you have ANSI, which is responsible for the regional standards implementation. And then you have the national standards for each country. So if you follow these 3 steps, you will have a standard that is accepted at ISO level, European, and then at the national level. For example, ISO EN/NP 17025, which is for the accreditation of laboratories, has been implemented in Portugal, also in Europe, and also then produced by ISO international standard organizations. There are some standards, for example, that are only used at national level. You can find in your countries some standards that don't have the ISO logo or even the EN logo. So that means they are only applicable in your own country. They are not accepted in any other countries in the world. And sometimes there are some European standards that are only used in Europe and not in the United States. So when you are using a standard, you can already see how is the impact and how wide is it used around the world. In terms of the ISO and SAN revision process, how is the life cycle of a new or revised standard? So when you are in a standard committee, technical committee, you can make a proposal for a document, and when you start this work, you will have a new item proposal. Then you go to the preparation stage, and that is where you have the working draft. Then you go to the committee draft standard, and then this one goes to the technical committee for comments. Then you have the inquiry phase, the approval, and the publication. So you already see here that there is a lot of steps in the way when you want to prepare a new standard. And in general, to have a standard, it takes around 36 to 48 months. And all standards must be revised every 5 years. And here you see why it takes so long, because there are all these stages that all of them have specific numbers under the ISO website. So you have all these stages. Only if we advance in all these stages, we get to the publication stage, and all of them have specific characteristics and work in specific working groups or technical committees, depending on where you want to engage. So it's a quite long process, but when you achieve a publication of a standard, it's a very, very important document accepted all over the world. And now, how can you, as a researcher, working in the university, for example, how can you engage with standardization bodies and technical committees within the ISO? So there are special procedures that you have to engage in order to be access to the technical committees or working group. So first of all, you should do a research on which standardization technical committee or working group could benefit from your work. And this you can just go to the ISO website and seek from all the lists which are the technical committees they have, because they have more than 100 technical committees. And you can see from what you are working on, which working group or technical committee you actually can give some inputs. Then it's very important that you identify if your country is a participant or observing member. So ISO works with countries, not institutions by itself. So only if your country is a participant or an observer member, you are allowed to enter a technical committee. And if you are a participant member, you can vote in the standards. If you are an observer, you cannot vote. You can comment, but you cannot vote in the latest stage of approval of the document. So in case your country is following this P member or O member, you can register as an expert in this technical committee. And then you can check within the technical committee which standards are under review in the next year. This is very important, because if you join this, it's important to know what work they are doing, or even you can propose standards. So as an expert in a working group, you can propose a document. And if you understand that a relevant standard is under discussion, you should send some comments to it. And then you should try to attend all the meetings to defend the commons. So this is also a very important recommendation that I give for persons who want to enter in this world of standardization and want that their work be recognized within these institutions. If you present comments to some document that is new or entering in the market, then you have to go to the meetings when you send the comments to defend the comments, or nothing will happen in that following that comments. I can share this for you. That happened personally for me, where I actually sent 20 comments to a standard, but then I was not able to travel to defend the comments, and they were not accepted at all, because people did not understand what I was trying to change in the document. So sometimes it's really important, especially in technical content, that you go to the meetings where this is discussed, and then you defend and explain why did you make these comments and what do you want to change. So why do you want to change things? So this is the key part where you really have to engage to the standardization bodies. Now, I'm part of a European Association of National Metrology Institutes. So Portugal is part of Euromet, and Euromet coordinates the cooperation between all the NMIs in Europe in several fields like research in metrology, traceability in measurements, international recognition of the national metrology standards that are related to our calibration capabilities. And since metrology is the science of measurement, it is vital for scientific research, trade and industry, and our daily lives. And I'm sure Eric is going to explain this very well. But we need metrology every day in all aspects of our lives. And there are many examples. Just the water we drink from a bottle has to be controlled in terms of the quantity of impurities, so we are safe and can open a bottle and drink it. This is just one. There are many examples of metrology all over our daily life. So one very important aspect is to make research on metrology so we can improve our measurement capabilities and follow the increase and improvement of technology in the world. So every day new activities are being discovered, new technology is being implemented, and all of this needs validation from metrology. So Euromet has coordinated metrology research across Europe to provide the high accuracy, low uncertainty measurements needed both now and in the future. And we had 3 research programs that provided more than 300 projects. And one of them is Empire. And we have in each of these projects several different calls for different aspects in terms of health, environment, and one of the very important fields is the part of cooperation. And cooperation with other entities is fundamental. So Euromet cannot work alone. And since one of the target programs is standardization, because we have health, like I told you, environment, and then we have also standardization, industry, and SI. So since one of the target programs is standardization, we cannot understand which are the needs in metrology if we don't contact with other entities. So in this sense, there is a CEN-CENELEC cooperation group with Euromet that actually are meeting every year and understanding which are the metrology standards that are needed in the immediate future. So these 2 institutions, very important in Europe, get together and then decide which are the future of standardization and innovation in Europe. And this is one of the institutions that you can, or the group that you can check in CEN-CENELEC how they work. So this kind of group advise on projects that have to be done by Euromet regarding standardization. And in 2020, we had one project in standardization that was funded within these research activities, which is establishing metrology standards in microfluidic devices. It was a 3-year project. It will end today. I'm the coordinator of this project. IPQ is the coordinator of this project. And we had 17 countries from 12 countries all over Europe that were involved in this project. And this project had the objective of contribute to the development of globally accepted standards for microfluidics. So in my presentation now, I'm going to speak to you about two specific cases of metrology standards, one for microfluidics and another one for drug delivery devices. And this one is related to microfluidics, and this project had two main objectives. First is to develop consensus-based measurement protocols and guidelines, and then disseminate them to metrology standards. And in this case, to the committee, the technical committee ISO DC 48, which is for volumetric instruments, working group 3, which is microfluidic, but also industry and end users. So this project wanted mainly to create standards in microfluidics. And I have to explain to you what is microfluidics, because microfluidics is the science that studies the behavior of fluids through microchannels, and also the technology of manufacturing micro-miniaturized devices containing chambers and tunnels through which the fluid flow are confined. So you here see some very small pictures, and you can see here some examples of a microfluidic device, and one that we used 2 years ago very often was the COVID tests. So the COVID tests were done in a microfluidic device platform. Also, when we have pregnancy tests, they are also microfluidic device. So you can see that there are many microfluidic devices around us. So we have not thought as microfluidic devices, but they are really important in the world. And this technology is increasing very rapidly. One of the ideas of this technology, microfluidic, is to eliminate the tests in animals, and then these tests of drug discovery are going to be done in these very small chips. So this is the future also of microfluidic. It's to, in terms of drug development and the diagnostics, to start working directly in these devices instead of humans and mouse. So it's a very important field of activity, very new. So that's why we were interested in metrology, to help these people with this very new technology of around 10 years maybe, how to implement and how to make procedures, standardized procedures for characterizing these microfluidic devices. For example, for liquid properties, to dimensions, so the measurements of dimensions, which is these chips are very small, around 1 micrometer. Also, the measurements of flow, volume, also roughness and leakage. So you see here some example of some protocols that we develop within this standardization process to help the microfluidic community. And so how did we then transform the outcome of our activities into standardization? We were in direct contact, like I told you before, with the microfluidic group, working group 3, and we could send them this information, this technical information of the procedures directly to them regarding the interoperability of the instruments like dimensions. So the standard 22916, the microfluidic vocabulary, and the new standard for microfluidic pumps. So this project had a 3-year duration, and you could see already here that we helped with 3 new standards in microfluidics. There were no standards at all in this field of activity, so we were very successful in these terms that of dissemination, we could create and help this group to create 3 new standards with the inputs we got from our scientific measurements. And also we did this for working group 5, which is dealing with liquid handling instruments, and also working group 11 from TC84, the syringe. And another thing we helped was the group for organ on chip. So organ on chip is very similar to microfluidic devices, and they are a microfluidic device, but has an organ inside, well, a mimesis of an organ, and we test some drugs in this organ or in this chip. So you can see the very, very new technology in terms of diagnostic and testing of drugs. And there is this new group, Sensenelec Focus Group, that is working on terminology and engineering and developing of a roadmap standardization. And then our group from the MFMet could give some inputs to these standards. So, and how do we actually achieve this impact that you see there? We had regular participation in these ISO groups, and we could contribute to revise the new standards. We made new work item proposals. We presented the activities in the ISO groups, explaining the needs for metrology in a common languages. And we tried to include some of our key documents in metrology. And we also provide our technical reports directly to the secretariat of these groups. Also, the comments were sent by the consortium, and we were there to defend the comments. And in general, 90% of our comments were accepted. And also, we were part of this roadmap for the future for the next 5 years in terms of working in microfluidic devices. So this project was very interested in this sense that also could directly input the future work for standardization. Another project that I want to tell you about is the one for metrology for drug delivery devices that ended in 2023. And this project was a little bit different than the standardization project of microfluidics, because this one dealt directly with the health. And in this one, we wanted to develop also calibration methods, but directly related to drug delivery devices that are used in the hospitals. And why do we need also here standardization? Because if you have a deviation in your medication dose, this could have dramatic effects. And therefore, it is very, very important that you have reliable drug delivery devices with reproducible measurements when you are doing these infusion therapies. Therefore, it is very important that you have traceable measurements and calibration procedures that are suitable. And this can only be done if you develop the correct standards. So also in this case, we have developed several procedures for measurement of ultra-low flow rates. You also can see here some of the technology that we use. And from this, we produced a new Euromet Guide 27 that was actually released last month. And this is the guideline for calibration of drug delivery devices and infusion device analyzers. And all this information were also imputed in all these standards that you saw here. So I will not tell all of them to you because of the time, but one of them, very important one, is this TR-101 that is from Amy from the United States, that is a document very important for drug delivery devices. But from all the work that we did also regarding health and measurement of drug delivery devices, we could give inputs to all these documents. So in this case, what happened? We participated in 6 different ISO technical committees, and we give contribution to 11 revised standards. The majority of our comments, when we are dealing with metrology standards and metrology projects, we give them of metrological nature. We also suggested to include some Euromet guides and documents. And also the comments were sent via Euromet, not just one country. And in this case, in average, 70% of the comments were accepted. So this was a different community. The health community, the ones that are dealing with hospitals, are more difficult to engage than the microfluidic community. So this is another thing I want to tell you. So depending on the field of activities, you can have more or less success in contribution to the standards, depending on how open are the people to metrology. And in microfluidics, they are really open to metrology, and they understand the need that metrology has in the validation of their projects. In health, people have other concerns and they have other problems with the day-to-day life, with dealing with the patients and all the death and all the problems with money. So metrology in that case is not such a for them, not such a critical aspect of their work. But everyone should think that metrology can really improve standard development and boost the science in documents, because we can contribute to improve measurement procedures. We can give you some advice on to use more accurate instrumentation, how to control better your test conditions, how to use the formulas, and how to use uncertainty estimation information. And this is because the use of standardized calibration procedures leads to comparable, more accurate and reliable results, and this benefits industry and global economy. So here are also a very important key, which is the comparable. So if everyone uses the same procedure all around the world, it means that you should have the same results. And that means that everyone is measuring the same thing, and that benefits really the end users of our work. So I would like to thank you for listening to my presentation. I hope you could get some good information on how standards can really support metrology and users and your daily life, and how can you now engage with standardization. Please go to your standardization bodies or your countries, identify which are the ones you can contribute and act. So don't be afraid. People really want your opinion, and in standardization, we really need the experts to be involved, so we have better standards with more consensus information. So that is the key word I wanted to give you. Thank you very much for listening.
Thank you very much, Elsa. I would like to share my screen now and ask the audience to join us on the Mentimeter. Just a second. Okay. Can you see my screen?
Yes.
I would like to ask you to join us on the Mentimeter. Just use the code. Code is 82264596, or simply scan the QR code you can see on the screen and answer the question: how does standardization validate and improve measurement results? I will read the code one more time. We will wait for the participants to join. So the website is menti.com and the code is 82264596. We're going to wait a few minutes. So we have possible answers. Standardization allows harmonization of measurement procedures, leading to comparable and accurate results. The second one, standardization allows harmonization of measurement procedures, but this has no impact on the results. And the last one, I really don't like to use standards since my results are the best. Okay. Elsa, I'm going to give the stage back to you to comment maybe on these.
Yeah. So I'm happy to see that the majority of the people were really listening to my presentation. And of course, that the objective of standardization is to allow harmonization of measurements. And this leads really to comparable and accurate results. So the standardization allows harmonization, and this has an impact on the results. So the correct answer was the first, and I'm really happy that the majority of the people were really in the right responses. So I'm very, very happy with that.
Thank you very much one more time. And I will now ask Eric to join us.
Good morning.
Eric, the floor is yours.
Okay, thank you. Okay, I pre-recorded my my presentation this morning, so I hope in 30 minutes, metrology in 30 minutes is short, very short, I would say. So I hope I did a good job. So I'll start the presentation, and then it will take about 30 minutes. This presentation is about metrology. Please be aware that this PowerPoint presentation is for educational purposes only. The agenda of this presentation is as following. I'll first talk about VSL, the National Metrology Institute of the Netherlands, where I work, and my job at VSL. And did you experience this? And then I'll talk about metrology and the SI measurement units. I'll talk about BIPM, Euromet, harmonizing DIs. Then I'll go into how do we make measurement possible. And at the end, I will tell you what there's least to remember from this presentation. VSL, the National Metrology Institute of the Netherlands, works in the international measurement infrastructure around the world with our colleagues. And we have some tasks that we do for the Dutch government. We have some responsibilities because of that. And we provide services to our national and international customers. And you see here the three main subjects: research and development, and the performance of calibrations, and the delivery of reference materials. Next to this, we can do consultancy, R&D for customers, international projects and training. And we have 3 accreditations for the calibration of instruments, providing reference materials, and performing proficiency testing, so we can compare measurements and results from different companies. We do a lot more, but I'll keep it to this, as I think the presentation should be more about metrology. I was already introduced with just a few pictures from my past working at VSL. So I do that for 31 years already as the Chief Metrologist for Flow and as the TC Flow Chairperson of Euromet. Next to this, I do auditing for accredited companies according to 17025 and 17020, as well as being a peer reviewer for national metrology institutes and designated institutes, work I do around the IPM. So you see some pictures for me working, training in different locations around the world. And for example, we see a picture on the right bottom from a volume calibration of a large pipe prover in Dubai. When I talk to my friends, family about my work at VSL in metrology, I always try to come up with some easy ways to understand what we are doing and what are the difficulties in measurement. So I like take you along in this. So here, it's asking you some things and see if you can recognize it. Did you experience this? I filled up my car with petrol, and it feels like the volume displayed on the fuel dispenser is more than I expected, as the dial in my car was not in the red zone yet. Is this volume correct? I measured the length of a curtain I needed at home for my windows. I bought the curtain to that exact length, and it does not fit. How can that be? This morning on the news, they said it's 5 degrees Celsius outside, but it feels like it's freezing. I used the weighing scale to see I lost weight, but it is reading more than expected. For sure, this weighing scale is wrong. I'm sure some of these you will have also encountered in the past years. So I will use the first one later on to show you what you can expect, for example, when you are measuring volume, when you are filling your car. But let us focus first on metrology. So what's the definition for metrology? So I'm sure you all Google, we all have that question, and we come up with a word that we do not know, we start Googling. So for example, a lot of people are using Wikipedia to find these things out. So when you look at Wikipedia, it says metrology is the scientific study of measurement. But metrologists always like standardization. So we made a document, which is the GCM 2012, which is the International Vocabulary of Metrology. And in that, you can find all the aspects that you need for metrology and measurement. And there it says science of measurement and its application. And that's, of course, important because the application is the part that we all experience during our normal measurements. We use the application. So as a scientist, that you probably all are, you are asking yourself questions. So now we know the science of measurement. But what is measurement? So let's go into that one. So we can just follow the vocabulary because it has all the words in there that we can see. So in chapter 2.1, measurement is stated as process of experimentally obtaining one or more quantity values that can reasonably be attributed to a quantity. Quantity, what's that? So let's look into that. So in chapter 1.1, it says then about quantity, property, or a phenomenon, body or substance, where the property has a magnitude that can be expressed as a number and a reference. In the state then, in note 2, a reference can be a measurement unit, a measurement procedure, a reference material, or a combination of such. So you see here some measurement units displayed. But let's see, what is a measurement unit? So the vocabulary tells us about what is a measurement unit. In 1.9, real scholar quantity defined and adopted by convention, with which any other quantity of the same kind can be compared to express the ratio of the two quantities as a number. And note 1 says measurement units are designated by conventionally assigned names and symbols. So, for example, if we want to measure weight, we define, for example, kilograms. But there are also conventions that using the pound. So now we know that there are measurement units. We need base units to make sure they are all equal so that we can compare one measurement with another one. So the vocabulary then tells us about base unit in 1.2, a measurement unit that is adopted by convention for a base quantity. And in note 1, it says in each coherent system of units, there's only one base unit for each base quantity. And there are more than one system of units. For example, the SI, that we most of the time use in Europe, but we also have the US customary system, the USC as it's sometimes called, that the United States, for example, uses. And in the past, we had the imperial system that was used mainly in the Commonwealth world. And lately, it's still a little bit used in the UK. But of course, we like to use one system around the world. At the moment, that's still not the case. But to be honest, there is only one international system of units, SI. The other two systems that I showed before, USC and Imperial, if it's still used, are all traceable to the SI units. And the reason for that is that all the metrology institutes around the world use this to compare measurements, to make traceability to each other, if needed. So that means that wherever you measure pounds or inches, they are related to the meter and to other units in the SI unit. So the vocabulary tells us what the system of units is in 1.16. System of units based on the international system of quantities, their names and symbols, including a series of prefixes and their names and symbols, together with rules for their use adopted by the General Conference on Weights and Measures, CGPM. So here in this table, you see all the base quantities, so their names, length, mass, time, electrical current, thermodynamic temperature, amount of substance, and luminosity intensity. Next to it, you see the base unit, so their name, and next to that, the symbol. And these symbols are very important. These you need to use in standards correctly. So you cannot write meter, for example, with a capital M. It needs to be a small m. Same for ampere, there it's a capital A. So make sure when you write measurements, symbols, they are correct. What I see a lot, for example, is that the time measurement for hour, which is then related to the second, hour, is most of the time written as HR, where it should be just H, if you look at the SI measurement system. The measurement units change over time, the base units. The answer is yes. We changed them over time, and more knowledge was gathered and measured, so research was performed to make the measurements better. But also to make measurements over time reproducible, we need to connect the measurement units to something that we can always build on or fall back to when something goes wrong. So in the past, before 2018, we had a kilogram in Paris, or what we would call as metrologists the Grand K, that was per definition a kilogram. So that meant if it would fall, something would break off. That part that broke off was no longer part of the kilogram, and the kilogram became less weight. So to prevent this, scientists did a lot of research to connect all the measurement units to something we find in nature. So in 2018, during the last conference they had about it, the new SI units were adopted. And they're no longer the measurement units that you saw before, but they are constant from nature. And we know how to use that constant to make the kilogram, the meter, the second, the ampere, the Kelvin, the mole, and the candela. So in this picture, you see the constants that we now use. But as you can see, it's very difficult to see, for example, what is a kilogram. And that's not a problem, because that's what the National Metrology Institute take care of for you. And how do we do that? So we have the units that we can measure, that you will use in daily life. You have the constants, and the relationship between them is known, as you can see in the picture. But there's also the relationship between them, because you can already see in the units, in the picture, that there are, for example, joule per Kelvin, joule per hertz, meter per second. So how do we make those connections? Now, here in this graph, you can see how that connection is made. It's too difficult or too long of a story to go through it in this presentation. So it's nice that we have the SI units, but now we need to be able to use them everywhere to do measurements. So you need to make agreements that we all use them. So for example, the BIPM, the responsible organization for the SI units, need to talk to colleague institutes and organizations to make sure that the SI units are adapted. So both in legal trade, or email, but also used by accredited laboratories, in this case organized within ILAC. But also in the standardization in ISO, its SI units need to be used as a standard for measurement. And so here, for example, you see the joint agreement on methodological traceability that was signed at the same moment the new SI units were adopted in 2018. But how do you know when we take a measurement, it is correct? Because when we stand on the weighing scale, or we measure the length of our curtain, or we take a temperature measurement, and we need to make sure it is the correct value. So for that, we need metrological traceability, as we call that. The vocabulary also tells us something about metrological traceability. In 2.41, it states, property of a measurement result whereby the results can be related to a reference through a documented, unbroken chain of calibrations, each contributing to the measurement uncertainty. In note 2, it says then, metrological traceability requires an established calibration hierarchy. So what does that mean? On this slide, you see the calibration hierarchy. The hierarchy is presented as a pyramid. There's a reason why we use a pyramid for a calibration hierarchy, and I'll explain that in a minute. So in the top of the pyramid, you have the SI units and the responsibilities at the BIPM. And in the second layer, there are the harmonizing DIs that maintain the national standards and the primary standards. And in the third layer, you see again anonymized DIs, calibration laboratories, and notified bodies. And they have secondary standards and working standards. For example, NMIs, they do not work normally with their national standards or primary standards to do calibrations for customers. They use their secondary standards for working standards. In some cases, they will use the national standards, but that is not per se needed. And in the fourth layer, you can manufacturers and end users have their field instruments and reference materials. We're talking about a reference material. Are 4 layers enough? No. In some cases, there are more layers in between. As for example, in flow measurement, you sometimes have 6, 7, sometimes even more layers in that pyramid to come to eventually to the field instruments. This, for example, happens for high pressure natural gas flow measurements, where the traceability length or the calibration hierarchy is quite different from what you see here. The reason why it's a pyramid, you can see the pyramid becomes wider the further you go down in the calibration hierarchy. That means that the measurement uncertainty grows. That means for the national standards, the uncertainty is small, but for the field instruments, it can already be relatively large. And so you always need to calibrate an instrument, for example, a field instrument, with a better quality of measurement. So you need a secondary standard, for example, from an NMI, that has a much better measurement uncertainty, because otherwise you will not get to the correct measurement quality that you need. So here you see some measurement traceability or a hierarchy calibration chain. This is for a water flow facility at VSL, and you can see that on the top we have the more primary standards, and they end up in a water flow calibration facility that can measure at 3,500 tons per hour. And it has all kinds of steps in between to reach that goal. Here you see a picture of that facility. So you can make these graphs to illustrate the traceability chain from a lower standard to a higher standard. So to demonstrate that you always have to go to a higher standard when you're doing a calibration is a joke that metrologists make about the Zanzibar effect. This is about a retired ship captain in the harbor of Zanzibar. And he shoots his cannon every day at 12 noon. A journalist visits him to ask how he knows that it is 12 o'clock. Well, he says, every Friday afternoon, I go to the market and I also visit his clockmaker, and all his clocks are reading the same. And I adjust my watch. So the journalist thinks, let's follow the traceability, and goes to the clockmaker. And he asks, how do you know that the time is okay? He says, well, there's this old fool in the harbor that shoots its cannon every day at 12 o'clock, and I adjust my clocks. And if they both adjust the clocks in the same direction, 12 noon can become 12 at night before you know it. So when we saw the calibration highlighted, the pyramid, you could see that the BIPM was at the top. The BIPM is an international organization established by the Meat Convention, for which member states act together in matters related to measurement science and measurement standards. Too much to talk about the BIPM in detail, but know that they are the coordinator of measurement around the world. But as you can understand, if you have to work all through one world organization, it probably becomes very difficult to do all the measurements needed to make measurement traceability. So in the world, we divided up the countries into what we call a regional metrology organization. And for example, in Europe, we have Euromet. And there the national metrology institutes work together. If you want to know more about the BIPM, put a link here on the page that you can go to, and you can read and find out everything that you want to know about the BIPM. So in Europe, most metrology organizations like NMIs and VIs are organized within Euromet, which is the regional metrology organization for Europe. And there we cooperate with each other on research, but also to make measurements traceable and to compare measurement results with each other. And our capabilities are then uploaded to the BIPM website. It's is what we call the CIPM MRA, and that's to underpin the capabilities that we have. There's too much of a discussion to tell you exactly what it is, but basically we list for what capabilities we have. For example, in flow rate, I showed you the water flow facility to 2,500 tons per hour. And we then can say that, for example, the CMC or the uncertainty is better or equal than 0.04%. And our colleagues around the world check if that's correct. But even if we would do it at the Euromet level for all measurements, it's going to be very difficult. So we have several technical committees that focus on several items of measurement. And for example, I am at the moment the TC chair for flow. And in flow, we already have 4 subcommittees involving liquid volume, liquid flow, gas flow, and fluid speed. And so you can see there's a lot of diversity in metrology. So to focus on certain items, we have made these technical committees so we can focus with the correct scientists and metrologists to work on the correct measurements. So you can see there are quite a few technical committees. So the local national metrology institutes and designated institutes, they are of course appointed by the national governments in that country. And they have a few items they are put into place for. And that's of course, for example, the primary measurement standards of the country, the measurement traceability, the role in the national measurement system. They have to, do the work in Euromet and the BIPM. And so international collaboration for both comparing the measurements, standards, and research. And support for innovation and industry. So that means that we have to make sure that innovations can take place. So measurements should be in place to perform good measurements to innovate products. And if you want to see something from our institutes, you can go to gsl.nl and IPQPT, and it explains much more. So let's go back to the original question. I filled up my car with petrol and it feels like the volume displayed on the fuel dispenser is more than I expected and the dial in my car was not in the red zone yet. Is this volume correct? The answer is yes, within the tolerances of the local legislation based on international directives. Today, the tolerance in most countries is plus minus 0.5% of the volume indicated on the fuel dispenser. In the past, it was 1%. But that means that within the tolerances, you should get the correct volume. Over time, as you can see, it improves the accuracy because research of the instrumentation to measure petrol and diesel was improved. And we are still innovating fuel dispensers for more difficult liquid and gases to be measured. Think about LNG and hydrogen. And in the following example, I will show you something that we did for LNG flow or volume, measurable at cryogenic conditions of minus 162 degrees Celsius. So the challenge was there was no measurement at minus 162 degrees Celsius. But the trucks are using LNG as a fuel today. So we need to start measuring it. So first, there is the need for measurement. Then we need to make innovation to make measurement possible. So we developed at DSL, for example, a calibration facility to make measurements possible for LNG flow meters that are then used in LNG fuel dispensers to be used. So now, today, it's possible to measure LNG, but with a less accuracy as you saw before, because at the moment, the fuel dispensers have a tolerance of plus minus 1.5%. And that's because it's very difficult. But in the end, we like to go to 0.5%. But then we need to still improve our measurements. How are we done when we can measure something? We need to ask ourselves the question, what is the measurement uncertainty we can achieve and what does it affect? This is uncertainty good enough to prove verify measurement instruments that need to operate within the tolerance set in written standard and legislation. Do we need to update the measurement standard to meet the written standard? Achieve low measurement uncertainty. How do we do this? Think about the allergy example. Do we need to feed the fund information and measurement methods into written standards or update standards? Making tolerances smaller or maybe less optimistic, in other words, realistic. Over time, technologies will be developed and NMIs need to keep up to make measurement possible and develop better measurement standards to decrease the measurement uncertainty to make innovations possible. So we need to be in front of all the measurements that will be done in the field. Written standards need to be updated when new information and research is available, or at the time when measurement needs to be improved for whatever reason. So what to remember from this presentation? Metrology is the science, measurement, and its application. Measurement needs to be traceable to higher measurement standards. Metrology in a circle does not work. The measurement uncertainties and accuracies or tolerances need to be known and well specified in any document, written and performed measurement. So make sure they are realistic. Use the vocabulary made by the international metrology communities and written standards when talking about measurement. When we talk about the measurement error, everyone should know exactly what the definition is. Someone thinks it's a different definition in metrology, mistakes will happen, and accidents will for sure happen after. Do not invent the wheel, talk to analyzing RMOs when measurements are needed in your work. Make sure the measurement is beyond all doubt. Thank you. And if you'd like to be in contact with me, you have some information here on this slide. Okay.
Thank you very much, Eric. I'm going to share my screen one more time and ask the audience to please go once more to our favorite website. Just a second. Join us at menti.com. Use the code 27219188 and answer the question, what are the constants of the International System of Units, also known as SI? A set of artifacts kept at the head office for metrology called BIPM in Paris, like for example the kilogram and the meter. A set of constants made up by scientists and metrologists to realize the SI, like the kilogram and the meter. A set of constants in nature, like the Planck constant and the speed of light to realize the kilogram and the meter. Or every country has its own constants to create, for example, the kilogram and the meter or pound and inch. We will wait a couple of minutes. Okay. Eric, maybe back to you to comment on these.
Well, I see that most of it, they have it correct. Yeah, this is of course always difficult. So to be able to measure today and in the future. So in 2018, we made sure that the constants are related to something we find in nature, like the speed of light. that we already use for over 50 years now to make length measurements. Also the time, for example, we have the frequency of an atom that we can measure, and with that we can always go back to the measurement that we want, so related to that. And I can understand that artifacts were in the past used, like the meter, for example, but 50 years ago we got rid of the meter. And in 2018, we decided to leave our prototype to kilogram 2. We still need it today, actually, but hopefully in the next decades, we can say that we don't need, for example, the grand K, as we call it at BIPM, no longer. So there are constants of nature. So everyone, even you, could realize a standard, if you know how the relationship works, of course.
Thank you very much. Thank you very much for your presentations. I will give the floor back to Ivana.
Thank you so much, Elsa and Eric. I would like now to start our Q&A session, and allow me to share the screen, and we have some questions in our Q&A session. First question is related to, do you have any information on smart standard or machine readable standards, and how metrology aspects can be correlated with new mechanism of standardization, if I can say something like that, like machine learning standards? Do you have any information about that?
No, Ivana. At the moment, we, at least in the technical committees I'm working, we are not working with this new technology yet. So we are just working with the new ones, but it seems to me that it's a challenge to be working with this new technology. So let's see if metrology can keep up with these machinable, readable documents. But I suppose it will be possible. But it's something that I have no experience at all at the moment.
Thank you so much. I would like to ask you, Elsa, you receive Sensenelec Innovation Award. Is there anything which was changed after you received that award?
Yes, actually, thank you for that, Ivana. It changed the visibility of the metrology work in standardization, actually. Not only for me, but also for my colleagues at Euramet, and also for the colleagues in the projects I work for, because they realized now that it's really important that metrologists are directly involved in standardization development, because we really can contribute to the technical parts of the documents with very, very accurate inputs. And I think this award gave them that idea that really the standardization people valorize the contributions of metrologists in their work. So now I think that people are more aware that metrologists should go to the technical committees, should give inputs, and there is actually a lot of recognition from standardization about our contributions there. Not only metrologists, but general scientists in general. So this was actually for research, the award. So I think it opens people's eyes a little bit that research fellows or people working in research and metrology are very welcome in Sensenelec and ISO work.
Thank you so much. I will first ask Eric, then again you, Elsa. Eric, do you have experience in training and education? Do you have any advice how to make metrology closer to researchers, to European researchers?
Yes, I think it's very important to make the measurements correctly. So training in that case is I think vital, just to understand, you know, for example, how you take a measurement. For example, just as an example, I know there are some videos that you probably can see on YouTube or something like that, where people measure the length of your body. So how tall am I? If you stand up, you are shorter than when you lay down. So it's very important to know the conditions of measurement. And Elsa and myself also work in volume. And in volume, the temperature is very important, because if I would send a volume instrument to Elsa and she would measure, say, at 15 degrees Celsius, or I would do the same thing at 20 degrees Celsius, then we find a different volume for the same instrument. So it's very important to do the education on more than just taking the measurement, but also to know the circumstances in which that measurement is taking place. One example where it went really bad for someone is that, for example, this was with measuring explosive liquids that already are very combustible at, say, 30 degrees Celsius, where in a standard it was standing that the measurement should be taken part in the normal condition of the environment. And that's, of course, when we talk about that in Europe, we would probably say 20 degrees. But for example, in Asia, this was at 30 degrees normal working operation, and actually the lab exploded. So it's very important when we state, for example, what are the conditions for this measurement. This should have been at laboratory conditions of not more than 21 degrees Celsius, for example, because otherwise you cannot take that measurement. So it's very important to know not just the measurement, but also the condition, and you have to train this. You know, these are the small things that we never think about. And let's be honest, if we are in schools and universities, how many times when you take a measurement, we talk about the measurement uncertainty. There is a very good YouTube video of Walter Lewin, which is a professor at the University of MIT. And in his first lessons in science, he tells about, you know, that the measurement without the knowledge of its uncertainty is meaningless. And that's true, because I can say I'm sitting here behind my desk. I can tell you it's 2 meters, and then you say probably it's not, and I say okay. But if I say it's 2 meters with an uncertainty of 1 meter, I probably did a bad measurement, but my statement is still correct. So now I know that the measurement, you have to quantify the quality of the measurement, and that's what we a lot of times forget, and that's very important. And unfortunately, like I say, in schools this is not trained as well, and this is important, I think, especially if you do scientific work and you want it to be repeated in the future somewhere else. This is what you need.
Thank you so much. Elsa, do you have any advice how to make metrology closer to researchers, to European researchers?
I think actually, Ivana, this kind of training activities are very, very useful, because it provide us to reach audiences that normally in our daily lives we don't reach. So I think the cooperation with other entities outside metrology world are very important. And so I hope that we can make some more of this kind of training activities. And also the projects that we have in Euramet also promotes this, because we include researchers from universities and also industry partners. And so that means that we actually can have a lot of contact with the people outside metrology. Another thing very, very important is that metrology starts to speak a common language. So I think also it's very important. We use a lot of very difficult terms, but we are trying to get these terms more close to the end users community. So that is also very important, that we can communicate all our activities, but also in a language that the end user can understand. So I think these two things, very good contacts with the outside world and the good common understanding language, I think will help us reach out to the scientific community.
Thank you so much. If you agree, we will close this session. Just let me provide to all of you a few information about Aegis Booster Training Academy. You can find 25 written text materials at our Aegis Booster Training Academy portal, and of course we are looking forward for new chapters in our training academy. And of course, what we are very proud of our Aegis Booster training sessions. Up to now, we have 9th, and you can see them all, and you can watch the videos on our YouTube channel and Zenodo. Right now, I would like just to inform you that our next online webinar will be on June 7th, and it will cover standardization for digital product passport. I would like to invite you all to come to our joint online webinar with Stand ICT project. And I would like to announce our new training session on terminology standards. We have colleagues from Norway who will explain us and let's say provide some sort of introduction to aspects of terminology, importance of terminology, and some experience in building terminology standards. Our next training session will be on June 11th. Thank you so much for participating to our training session. I hope that we will see you soon. Elsa and Eric, thank you so much for providing us insight in magnificent world of metrology. Thank you so much.
Thank you very much, Ivana.
Thank you. See you soon.
Bye-bye.
Bye-bye.
Bye.